All right, people, I'll begin. Okay, so what we have done so far is understand what NumPy, Pandas, Seaborn, and Matplotlib libraries do. All right, today we are going to see how they work when we are actually trying to clean a data set. Okay, what cleaning means is that, for example, there are some rows in your call in your data set where the values are there are no values. Okay, everything in that row is null. So what you need to do is remove that row completely, right? Because when you are analyzing the data, that row is not doing you any good. Or maybe if, for example, there is a row that has all the time values in it, but somehow, for some reason, uh, in one particular row, there's written ABC instead of the date or time. Okay. So that those are the things you need to clean from your data so that when you process these things into your machine learning algorithm, the model that you make, it can understand what is happening. Okay, because the machine cannot say, ki, okay, this data is wrong. It will just take that data and give you the incorrect results. All right. And for example, if there is a column for weight and everything is in kgs, 60, 70, some kind of values, and then in one column you have 50,000 written. For some reason, it's 50,000 instead of just 50. So the machine cannot understand that that value is wrong. It will give you the calculations, the output, everything based on that 50,000. But you understand that that is not possible. So what cleaning means is that cleaning and pre-processing. Pre-processing is you process it before you add your data to a model. Okay. So I'm going to show you how to do that. This is called exploratory data analysis. Okay, the cleaning and pre-processing of a data set, it is called EDA. Okay, I'll show you how to do it. I'll show you a couple things, and this will also be your assignment. So please listen very carefully, okay, how to do these things. The first thing you need to do is go here, upload your file. Okay, this is the one we are using. See, it's getting uploaded. And once it does upload, you have to click refresh. And every time you load your kernel, you'll have to upload this again. Okay, because it will only be uploaded for as long as you're using it. The moment you stop using this data, it will disappear from here. Okay. Okay, so this is done. Now what you do is you import your libraries first of all. And then you click here and you copy the path. And that is what you will paste here. Okay, this is your path inside Google Colab. Okay. And then you load that. So now you have a data frame from your data set. Now you don't know what it looks like, right? So the first thing you need to do is see what it looks like. And that can be done by df.head. Okay. So these are all the values here. Okay. Now the first thing you see is that there's an index column in your data set, but since we have kept it in a data frame, we already have these index values, okay, and they're matching. So there's no point in keeping this index column, right? So we drop that column from here. We drop the index column, and what in place is equal to true does is that it changes your original data set. Okay, if you, for example, you load it again, you have to load it again because for now, since you ran this columns, this cell, so the index column is already not there in your data. So you have to load this again. So DF has the original data set with the index column. Now you do in place is equal to false. Okay, so you get this and you see there's no index column here, right? That is exactly what we need. Now you do df.head once again, but the index column is here. Okay, so what in place is equal to false does is that it will create a new data frame that won't have this index column. But if you do in place is equal to true, and then you print df.head, see, now the index column is not here in your data frame. Okay, and axis is equal to 1 is for your column. If this was x is equal to 0, then it would have been for a row. I have written these comments, so when you run this by yourself, you can see what are the things that are happening. Okay. Now the next thing we do is we see the name of every column. Okay. It will be an object type. And what you need to see here is that for every column, when you read this column name, you should understand what is there in that column. Okay. You see the job title, type of ownership, industry, sector, revenue. You see everything and you understand, okay, this is what is there in the data. If it had, for example, if instead of salary estimate, it had maybe say numbers written, you would not know okay, what kind of numbers are there. Okay, so you would have to change that column name. And one thing you need to note is that when you are doing your EDA, it is not only for you to use. Okay, whenever you do that in the real world, it will always be for a lot of people to use. A lot of people will see your EDA analysis. Okay, they will see the things you have done. So everything you write, you have to either make a comment, write it as a comment, or write it as maybe insert a cell and write it inside. Okay, this is the next step we are going to take. So anyone who sees your EDA for the first time, they can understand what is happening. All right. Okay, now we see the shape of it, which means how many rows and columns are there. So that 672 rows are there. This 672 will help us when we do df.info. I'll show you how. And we have 14 of our columns. There were 15 originally. If you had done it before dropping index, there would have been 15 columns. But for now, we have 14 of them. And then you do df.describe. So what describe does is it counts the number of values, mean, standard deviation, the minimum value inside that column and the maximum value inside that column, and the 25th, 50th, and 75th percentile. It gives you all the statistical descriptions of your columns. But you see, we had 14 columns here, right? But we did when we did df.describe, we only got the values for 2 of them. Why is that? This is why. Okay, see, we got these values for the 2 columns rating and founded, right? So rating is a float data type and founded is int data type, right? So the thing is for statistical descriptions, what you need are numbers, right? In other columns, we have an object data types. For example, when for salary estimate, this should also have been a number, right? But you see, we have this dollar sign, we have this K, we have dash, we have this Glassdoor estimate written here. So there's a lot of things that are making it difficult for the program to give you a proper statistical description of it. It cannot average this out, right? Because it does not know what this dollar sign it does not know what class you're estimated. It does not know things. So everywhere you see rating is a number. That is correct. Founded is also a number. That is absolutely correct. And revenue, again, there's a lot of different things that are disturbing the values. Okay. So when we do EDA, it is our job to correct these. Now, thankfully for this data set, there all the values are non-null. Okay, so there were 672 rows. Okay, you see 672 rows, and all of them have non-null values. If this was say 670 for all of them, then you would know that there are 2 rows in which there is no value anywhere. So you would need to remove those rows from your analysis. Okay, and if there was only one column, say this one, and it has only say maybe 100 values. Okay, so then you would need to remove this entire column because it is of no use to us if it does not have values. It's basically 1/7 of the entire data set. So 6/7 is empty. So you need to remove that column because it is not giving you the information you need. Unless, of course, it is an extremely important column. Then you need to figure out ways on how to make the data count. Okay, now I told you about the salary estimate. Now we are going to correct this. Okay, we are going to make it so that it becomes an integer value instead of an object data type. So what you need to do is find the unique values from it. When you do that, you will see, okay, that every value you have, it absolutely has this Glassdoor estimate written here. Okay. And or in one value, you have employer estimate. All right. The one common thing in them is that they are separated with this. Um, Hello. Okay. Um, okay. So what you do is for the salary estimate column, you apply it. Apply means apply to every element X of this column. Okay. So what the thing you are applying to it is that you're splitting the data based on this bracket. Okay. And you are getting the first value from it. Okay. See, when you split it, for example, for this value, if you split it based on the starting bracket, the first value you will get is this one, and the other value you'll get is this one. So this is completely useless to you, and this bracket will be gone because it is splitting the data, so it would be gone. So you need the data before this bracket, not after. So the after one you can completely ignore. So you take the data before, and that value you put in your salary estimate column. And now if you print your unique values, oh wait, I didn't run this. Okay, now if you print your unique values, there you go. See, now you have this. Now you can argue that maybe we could have separated it based on the space, but you see, if you do it based on space, when you do for this one employer estimate, there is no space here. Okay, so you would have to do it again for this particular value. Okay, now you see it's still not an integer data type. It has this dollar sign, it has K sign, it has a dash sign. There's a lot of disturbing things still, and the data type is object because it cannot convert a dollar and K and dash into an integer. So what you do is, again, you apply this particular thing to every element of this column, and you replace the K with nothing, and you replace the dollar sign with nothing. Okay. We don't do it with dash because dash is what is separating 137 from 171. If you remove the dash as well, then this value would be 137171. Okay. It wouldn't be 137 to 171. We'll look at that later. So the first thing you do is you replace them with nothing. This blank is nothing. Okay. And then you print the unique values again. See, you get this. Okay. It's still a little problematic because we don't have the integer values. Now, what we need to do is we need this value separately and we need this value separately. Why? Because this is the minimum salary a person can expect from that particular job, and this is the maximum one, right? So what we do is we create two different columns. Okay. The two different columns, there is one for minimum salary estimate and there is another one for maximum salary estimate, right? Again, we apply this to every element and we split them based on the dash. This is also why we did not remove the dash. We split it based on the dash, and the first value of the before that dash is your minimum salary estimate, and the value after that dash is your maximum salary, right? So we do that. And then we print df.head. Okay, there you go. Here, all values, minimum values are 137 in the head and maximum are 171. So that is exactly what you get in minimum and maximum columns. Okay. Okay, the next thing you see is that the company name, this is sorted. You can remove this salary estimate column, okay, because it is not necessary anymore. This is where we drop it. Okay, so that's dropped now. And then you print this and it is gone. Okay, you only have minimum and maximum salary estimate columns. Okay, the unnecessary one is gone. Now the next thing you see is in the company name, it has these disturbing values. Okay, these are, if you see closely, these are the ratings. that are added in the company name. Since we already have a column for ratings, we do not need them added in the company name and disturbing the data. Okay. So in order to see if there is this \n that can be used to separate these values or there is something else. So we do df company name dot unique. And all right, if you notice carefully, you would see that maximum of them either they don't have this \n, and if they do, they have the rating as well. Okay, so that is what you would notice. So you split the data again, and you take the first value before the \n, and then you print the unique, and there you go. You have all the company names nice and proper, exactly as we need them to be. Again, you print df.head, and these columns are clean now. Okay, now one thing I need you guys to see is, okay, okay, yes, one other thing. When you do this, you should type as type int. Okay, this helps in making the wait, we don't have that. Okay, this we did this because this had the data type of an object, right? So this will treat 137 as an object too. Okay, so when we are splitting it, it takes the value of 137, but is still an object. So when you do as type dot int, so you're converting this into an integer. And since it's 137, it can easily convert it into 137 as an integer now. Okay, so it sees this as an integer now. So that is done. Okay, now, okay. I want to show you something you have not learned it yet. It's used from sklearn library or scikit-learn. Okay, sklearn is used for a couple things, and one of them is called label encoding. Okay, label encoding is, for example, you have a column where there are values, say only male and female. Okay, and if you put that value in a machine, it won't understand what male and female are. It will consider them as strings. Okay, that makes it difficult for the machine to do operations on it. So what you do instead is you convert, for example, you convert male to 0 and female to 0. Okay, you can do that based on the replace as well. You can replace male with 0 and female with 0, but that works when you have very few values, right? And if you have, for example, you see the sector here, right? See this business services three times in the first five rows only. One is insurance, one is manufacturing. So you see how many unique values are there in the column sector. And there are not many of them. There are pretty much okay. So what you will do is from sklearn pre-processing, you import label encoder. Okay, this is what are the other things that sklearn can do. One hot encoding is pretty much similar to label encoding only, except it is used for binary classifications. Okay. Now there's scaling and normalization, and there's splitting of testing and training data. Okay, when you are training your model, you have a whole lot of data that you'll train it with, but from that some values you will use to train the model, say 90% of the values you use to train, and 10% will be used to test your model. Okay, because those are the answers you already have, and then you will use it on future data or some data to predict what will happen later for things you don't know yet. Okay. Okay, so how you do it is you store this label encoder in a variable, for example, LE. You do fit transform. You create a new column sector encoded for the column sector. And then you create a mapping. This mapping is important because otherwise you wouldn't be able to understand ki, okay, there is a row which has the sector as 5, but what is that 5? You would need to know at some point, right? So you need to create a mapping for that. You create a dictionary for sector encoding unique value, only unique values to sector, unique values of sector. Okay. And then you print that. Okay, see. Now, wherever the business services sector is there, you would see 5 in its place. Okay, so we had C, 1, 2, 3. We had 3 for business services, and in sector encoded, we have 5 written instead. Insurance is 13 and manufacturing is 14. Now, if you would like, you can drop this column now, this sector column, but you would need to save this value. Otherwise, this would be lost. Okay, now because you are cleaning your data, you can also arrange this by rating, because if someone is coming asking for looking for a job, they would want the rating to be high, right? So what you do is you sort the values by the rating column. So these begin from 5 and they end at -1. Okay. Now you find the, okay, huh. So when you do this, you see that founded has the values -1 in them. Okay. Now this is not possible since -1 is not exactly a real year, right? So that cannot be true. So these are just values that are unknown, but you need to convert them. So one way of doing that is, it won't work. It won't be a good method to use here in founded column, but you need to understand that this is what happens in many columns. For example, you have the height column or the weight column. So this is the method that you use there. You find the mean of that. Okay, you find the mean of that column. The mean founded, you store it in a variable called mean founded. For the founded column, if founded column is not equal to -1, you will not include -1 in your calculations, because otherwise you will get incorrect results. So you don't include this in your results. And then for founded, you replace the -1 with mean founded, and you do the as type dot int. And then you print the unique values. See, they're here. Now, okay, this is extremely important, because if you don't do this here, see what will happen. I'll just, no, wait, I'll show you it later, because you need to see this first. Okay, that is done. If you plot a correlation graph, correlation is which column is related to the other column, how. Okay, now see, earlier when we did df.describe, we only had 2 columns, right? But now if you do that, there's more columns here, because these are the columns we changed. These are the columns we converted to int data type, right? So you understand that the mean or the minimum salary is 31 and the maximum salary is 331. Okay. And the same for sector encoded. This is not needed, but it's there because it's converted into int data type. Now for correlation graph, you see that one symbolizes perfectly linear relationship. Okay. It is proportional. Okay. One implies perfectly proportional, and -1 implies the inversely proportional relation. Okay, if you get a proportional relation, that is good. If you get an inversely proportional relation, that is good as well, because um because even if it is inversely proportional, it is still a relationship. If one value is increasing, the other is decreasing, so that makes it a good graph. Okay, so you see here that maximum salary is very closely related to the minimum salary estimate. If the maximum salary is increasing, then so is the minimum as well. Okay, and that is obvious. That is something that should happen. But if you get values like 0, .0, -0.07, these are things that are not related. These are not any relationship at all. 0.3 is might be considered a relationship, but it is not exactly a relationship because the values need to be as close to 1 or as close to -1 as possible. Okay. And that we only see in maximum and minimum salary estimate, which is to be expected. Okay. And then you plot the same thing. Okay. See, when you, in this one, you only have 5 columns. Okay. But when you do your EDA, you will have maybe 30 plus columns. You cannot like exactly find the values, read them. That would be very confusing for you. You might miss a lot of things. So what you do is you plot it. Okay. Like this. This is called a correlation map or a heat map. Okay. Heat map is, it's pretty much the same thing. It only has the same values, but it makes it color coded. Okay, so you know white is here. So the closer the values are to this light blue or white color. So these are the values that you need. Okay. And if in this one we only have these values till -0.2, but for larger variables you might have these values to -1. So you will need to see the -1 colors as well and 1 color as well. Okay, then you can easily find out which columns actually have a relationship between them. Okay. And you can also do a pair plot of these. Pair plot plots the graphs for every column to every column. Okay. See, for every column to every column, you get a graph. And see, this is the minimum salary estimate to maximum salary estimate. See, you see how this is a linear relationship that you're getting, right? This is the kind of relationship we need, because if we create a line here, if someone gives us the maximum salary estimate, for example, we can find out maybe this might be the linear minimum salary estimate that is possible for that particular value. You see this and this. Okay. Now, the one thing I wanted to show you was the Aztec thing. Okay. I'll just get the original data frame. And then for the founded values, if you do this, you get the same thing. There's -1 here. And then you do this without as type. Okay. Okay. See, this is what it does. Now, I'm pretty sure you would agree that 1984.1046 is not exactly an year. So what you do is you do as type.int. That makes the things better. It converts it into an integer, the float values to an integer. Okay, you saw now that this had float 64 as its value, right? And now it's an integer. Okay, now it's 1984 only. Okay. Now, if you have any questions, you can ask them, and if not, you can leave. This is exactly what your assignment is going to be. You are going to get a data set, and you are going to have to perform the whole entire exploratory data analysis, EDA, on that, and you'll have to submit it by 21st midnight. Okay, I'll send you the data sets. I will give you data sets, but you can choose them on your own as well. I just need you to understand that whatever you plot, okay, this is a pair plot, so it plots everything. But if you for example, if you have a columns, you have your columns, say index, weight, and height. Okay, so if you plot a graph, specifically plot a graph for index and weight, then it does not matter because that does not give us any information. Okay, but if you plot a graph between height and weight, then yes, that would give us some information. Okay, that should have a relationship between them. And one thing you need to understand is that it is possible that maybe you have a relationship between two columns, but it is not necessary that they actually have a relationship. For example, say you are analyzing some data about a beach. Okay, now for that beach, you plot graphs for every column, and you see that the number of deaths by drowning are proportional to the number of children buying ice cream. Okay, that is what your data tells you. But you need to apply your common sense or the facts that you know that that is not possible. Okay, even if a lot of children are buying ice cream, that has absolutely no relationship with the number of people who are drowning. Okay, there's a completely different reason for drowning. Ice cream has nothing to do with it. So your data might show you results like that, but you need to understand that just because your data shows it does not mean that they actually are correlated to each other. Okay. Okay, that's it for today, and all the best for your assignment.